My name is Mohit Sharma. I'm a Salesforce CTA and the CTO for Salesforce at Capgemini. So that's more than now almost 18 years of experience in the industry, primarily in CRM domain. Yeah, I did my CTA in 2021 when I was working for Salesforce. And then I joined Capgemini in 2022. And before that, worked for various consulting companies. So that's a brief intro. Of course, Agentforce is 2.0, of course, is a huge focus area for us and agentic AI. So today, the idea is that we will go a bit deeper in Agentforce under the hood architecture, because we need to understand how things work, but more importantly, how they are built and what are, let's say, the limitations, what are the items on the roadmap, and how the agentic AI landscape is evolving. So let's move further. So yeah, that's my title and Capgemini. So before that, let's try to identify. So you know Einstein Copilot, right, which is the predecessor of Agentforce. And now, of course, when Salesforce launched Agentforce, there was a reason, right, why Einstein Copilot kind of evolved into Agentforce. And some of the reasons, right, I mean, apart from Agentforce is better, we need to understand what were the key limitations, right? The first one was limited adaptability. How many of you have worked on Copilot earlier? Okay. And did you face any challenges while working or not? Okay, so the challenge was more about adaptability. So the challenge was that if you are starting an interaction with Einstein Copilot, uh, it follows a technique called chain of thoughts, COT in AI terms. And the challenge with that pattern was that if you are going in a flow in sequence of the conversation, all try to disturb the sequence by asking something else. So and the co-pilot has to kind of again get to that context. That was the challenge. Adaptability. Now, consistent quality, even though it was better than basic chatbots, the interactions lacked genuine human touch or nuance. Context usage, that was another thing, right? Difficulty maintaining context. So that was also kind of related to the adaptability. So when you start interacting with an agent, there is a context, right? You are talking about cases, the customer is facing a problem, there is a context. And then then you are moving on to some other area. So let's say a customer starts interacting about a case, there is a issue, start talking about that with the support agent, and then in the meantime, the agent recommends solution. Now the customer wants to move to a selling part, right, or wants to buy something else. So it's a different context, but then for co-pilot, it was difficult also kind of go back, and have the context of the conversation in still the context window, right? So it was not taking the holistic context of the conversation while suggesting the responses. So that was another challenge. Scalability challenge, that was a major challenge, because when Einstein Copilot was deployed to handle a number of tasks, um, it was not scalable enough. It was doing an okay-ish job. It was not scalable enough. We built a solution last year on Copilot, and some of these issues were, of course, quite visible. And the good thing is that Salesforce being a platform, they always try to listen, as a company, to partners, to customers, and this feedback was shared with Salesforce team. So React prompting is where you do a reasoning loop, right? So there is a prompt, the agent will reason, then kind of act, then observe the output, then again reason, then act and observe, right? So it allows you to go on an iterative loop before actually coming up with the response, right? And the reason why, because you can go back, observe the outcome, and then again try to iterate and improve over that cycle. That's the reason why React and Agentforce now agents are more advanced, because now you can go back. It's more flexible. The context is maintained. This was something which was the key, introduction in the architecture of Agentforce, right? The pattern, because the chain of thought was not working. And I would encourage you all, if you are more interested in AI, to also look for some other patterns. So there is a tree of thought, there is a chain of thought, then we have React, then there are some more, right? And try to understand what are the limitations when it comes to building agents, not only on Agentforce, because in Agentforce you don't get that flexibility, right? Because it's a platform. So if you are building agents on Agentforce, you have to stick with React. But then there are certain other algorithms which you can use or pattern for other use cases. They might be better fit there, right? If you are building agents beyond Agentforce, right? Because the topic of this presentation today is not just sticking to Agentforce, but what are the other things evolving in market. Now, second thing was topic classification. I told you about Einstein Copilot that there was a scalability challenge. And the challenge was because there was no concept of topics in Einstein Copilot. And what is topic in Agentforce is that, let's say you are talking about a case, and you have what in Agentforce you can define a topic called case classification. So what the Agentforce reasoning engine will do is, when you ask for a case, for example, can you summarize my case? Number is this. It immediately identifies that we are talking about a case, and tries to identify a topic within that Agentforce. And one agent can have multiple topics, but then it only identifies that single topic which is relevant for the query or the prompt, right? And and with this you actually restrict the scope of the conversation, because now the agent has to really restrict itself to that one topic, because the prompt is about that. And then whatever the actions are assigned to that topic, only they are available in the arsenal of the agent. Now imagine or compare this to Copilot, where there was no concept of topic. You can ask anything with NLP. The Copilot was trying to identify what to do, right? And there was no concept of scoping it to a set of actions. So this topic classification was key architectural change for ensuring that the agents are more scalable compared to Copilot. The third one is LLM response, important one, because in Copilot, what was happening is you were asking Copilot, can you summarize my case? And then let's say there is an action, which is an action saying, okay, get a summary of the case, or maybe a standard action. And what it was doing is it was sometimes putting the raw output of that action directly on the conversation window. And if you're using Apex, for example, the JSON data sometimes, and you have to do some reformatting to actually make it a user, in the user format, right? That a end user can understand. What Agentforce is also doing now is that after those actions are invoked, then LLM again is used to frame user identifiable response or user acceptable response, where it follows the natural language which we humans understand and tries to bake that action output in the LLM response, right? So that's leads to richer conversations, and it also can understand the previous context history depending upon the LLM model which is used. And we'll get to the details of that. The fourth one, proactive action. Well, this is something which also an agent can do. Copilot was more like a conversation platform. So you have to really start a conversation by saying, hi, I'm this, can you summarize the case? But in case of Agentforce, eventually you will be able to also trigger an autonomous agent from a database operation. Could be like a new record creation and an autonomous agent taking an action on that. That's also will be part of this architecture is going to support that. So you will see that feature also. Now, I have already summarized, what was the difference. So these were the differences. Chain of thought reasoning for Copilot, limited adaptability, struggled with context. Agentforce React prompting. Maybe some other thing. Agentforce also with Agentforce, Salesforce launched RAG, which is the dynamic information retrieval. How many of you are aware about RAG? Okay, good enough, people. Let me try to explain that in simple language, maybe for others. So RAG calls for retrieval augmented generation. The idea is that you have, let's say, lots of knowledge articles in PDF format. Let's say you are a service company, you have lots of knowledge article for support reps. If you want to extract the unstructured information, which is written in a textual format in a PDF, in a knowledge article, how an agent can extract that information and use that to answer user queries. That is RAG. So what it does, it actually, you can create a chunk of the data of the different knowledge article of text, put that in a vector database, and then based upon the prompt or the question asked by user, Agentforce with the help of RAG can dynamically retrieve the exact policy. So let's say a customer is saying, what is the return policy for the product I purchased last month? Now, return policy is captured in a knowledge article, which a support rep refers to answer the question. Now, agent can directly get that return policy information from that knowledge article with the help of RAG, right? And it's super powerful because the knowledge article could be millions for a big enterprise company. So how can you dynamically retrieve that information? Now, of course, Agentforce also provides a transfer to human capability. It has an enhanced reasoning engine, and we are going to talk about that. Now let's look at, let's step out of the Salesforce word and move to more agentic AI general word, right? Like how things are evolving. So if you look at the agent architecture, right? This is how an AI agents work. So you start, the information flow is pretty, obvious in this, slide. But if you look at it, there is an input processing. So agent will have an input processing component. It could be a natural language. It could be a structured data. It could be a media content, right? And we are talking right now about Agentforce 2.0. Still, it's accepts text as an input, but we will talk about the future of that, and it's going to be multi-modal, where you can also put video as an input, right? Picture as an input, and the agent should be able to process that. That's why the media content, or an agent can also be triggered by an API request from some other platform. We'll talk about multi-agent communication, but that is what the input processing is is depicting there. Now, once the input is sent to the agent has something called a knowledge base, right? Knowledge base, RAG is an example of a knowledge base, right? It's a vector database. It has all the content of all the unstructured document or a structured data. So for example, in case of Salesforce, all your account contact records are structured data. Then you have your knowledge articles, which are unstructured data. All of them are depicted by something called knowledge base, right? So agent has access to a knowledge base. It has something called task planning. So moving on to the reasoning engine, for example, in Agentforce. So I'm just trying to map how Agentforce does all this thing, right? So it has all these components, but this is the architecture of a general AI agent. So it has task planning. So it can do sequencing. It can understand the context. It can identify the topic. It can plan what are the tasks. So for example, summarize this case. So what an agent will do. First, you will provide the case number. Agent will say, get case record. So that is one task, to get the case information. Then look at the description of the case, look at who raised it, what is the subject, and then create a summary of that case. That is the second task, right? So it does the task planning, that sequencing. So that's why agent. It has a reasoning engine. So reasoning engine is which actually decides how to execute those tasks and in which sequence, and whether the output of that task, those action, is really relevant, or can it be refined further. Remember React, right? the algorithm I told you. You reason, you act on that, you observe the outcome, you again use that outcome, again reason on that, again create a better outcome. That is the reasoning engine. Then you have tool integration. Tool integration is nothing but something at agent disposal for executing actions, or it could be custom function. In case of Salesforce, it's invoke Apex, invoke prompts using prompt builder, invoke flows. Now with Agentforce 2.0, you can also invoke MuleSoft API, right? So that's tool integration. You have an execution engine which is going to execute the action using the tool, using the task planned by reason, and then there could be an error handling or anything else which the engine is going to take care of. Now in Agentforce, reasoning, task planning, tool integration, execution, everything is managed by Atlas reasoning engine, and we'll talk about that. And then the response will be generated, it will be formatted using LLM, and it will be shared with the user, right? And then there will be system monitoring. There is an underlying security layer for Salesforce. All of you know the security layer. What's the security layer? Einstein trust layer, right? Einstein trust layer is there to support the security. So let's look at now the core components. We already talked about that, but this is another very nice diagram, I would believe. I believe which you can use to maybe have a more simplified look. So here you can see there is a user input, then there is an environment, right? Again, we are not talking about Salesforce Agentforce setup, but in general, environment is, for example, in our case, the environment is Salesforce platform. It could be AWS, it could be Azure, doesn't matter. It has a digital infrastructure, it has a physical infrastructure, and then eventually from that environment, the input goes to an agent. Agent has sensors, agent accepts the input, and then agent sends it to control center. Control center is what? Atlas reasoning engine in case of Agentforce, where it does decision making and planning, task planning, which we just talked about in the previous slide. It has a memory element, right? Remember, the context is maintained in Agentforce, right? Agentforce agent remember the context. How can an agent remember the context? There has to be a memory management happening somewhere. Then it has tools, like I mentioned. It can invoke a RAG, it can invoke MuleSoft, it can do many other things. And then it also learns. So there is a learning component as well. That is what I'm saying. So agent keeps on feeding the outcome of their actions into their, the LLMs powered by it, so that next time they can do a better job. That is the learning element. And then effectors is the outcome, the actions which are invoked, and the outcome which is shared with the environment and eventually sent to user. Now, this is a very nice white paper from where I have got this picture. This white paper is written by Capgemini in collaboration with World Economic Forum. We can share the link, or if you Google for that, I think you will find it. It's all in public domain, but a very nice white paper on agent architecture. Now let's now summarize what we have just learned for Agentforce architecture, right? And this is what we created, right, within Capgemini. So it's part of when Agentforce was introduced. So you have in the core we have Atlas reasoning engine, which is the brain of Agentforce. It takes care of the task planning, decisioning, executing the action. So basically, within the reasoning engine context, when a prompt is received, it does the planning, that what needs to be done next, what are the action needs to be taken. Then it can interact with an LLM. So that's why BYOM denotes bring your own model. Then it can reflect on the outcome. And after that, once the agent is, or the reasoning engine is satisfied with the response, it invokes an action, which is, the action is what? Could be flow, could be Apex, could be MuleSoft, could be a prompt, right? And then those actions could be Salesforce or external system APIs with the help of MuleSoft, which you can do. Now you can see here that the prompts are enriched with RAG. So RAG is what? Like I told you, when a prompt says, can you tell me the return policy? I have purchased this product. Here is my order number. Now, the order number is a structured data because you have the order history in Salesforce, but you don't know what is the return policy applied to that product, which was part of that order. How will an agent get that information? Because that information you will not get from a LLM, which is powering your prompt or interaction, right? That is your company's proprietary data. So that's why you need to enrich that prompt with the RAG, where you will get that information from your vector database hosted in data cloud, and it will say, okay, here is I looked at it, your order number is this, the product captured in this dress, whatever, this jacket, as per our company policy for this type of product, the return policy is 30 days from the date of purchase. Since your date of purchase was this, your product qualifies for return. Would you like to return it? Right? And that is all possible due to the combination of RAG and your LLM. Right? And then, of course, you have then you can enable it with omni-channel messaging. You can expose your agents on web, on your experience cloud, on WhatsApp, on different channels, right? So that's very important. One thing which you will notice here is that there is a block here in red called multi-agent. This is something which is still on roadmap. So this feature is missing. It's coming. We all know that it has to be there, but it's not there yet, right? That's why it's not really enabled as part of the architecture. Sorry. So multi-agent is that you have a team of agents working within the Salesforce platform, where one agent can receive an input from an end user and can offload the task to another user, right? So, for example, you have a manager. So I'm talking about, let's say, organizational structure or a project structure. You have a project manager. Project manager will collect the requirements, let's say, from end client, and then project manager say, okay, developer one, this task is assigned to you. Developer 2, this task is assigned to you. Developer 3, this task is assigned to you. So for example, in Salesforce platform, there could be a manager, supervisor, or an orchestrator agent, which receives the request from the end user. And then it says, oh, this query is for service domain because this is about getting a support for the customer. So let me route this request to a service agent. Exactly. Domain specific agents, specialized agents, and that will make this platform more scalable because you can have a sales agent, you can have a service agent, you can have a marketing agent, commerce agent, and all are specialized in their own domain, and they can seamlessly interact with each other, communicate with each other, and provide the right response to the user. You can build multiple agents, but the challenge is that there is the communication from agent to agent, that protocols and the framework is missing. And that framework needs to be there in the platform. We'll talk about that in detail because in agentic AI in third, at least in general, there are frameworks already available. And Salesforce has also thought about a framework. I'll give you the details as well. Yeah, but exactly. That of course, right now that is the only way, like you said. So you create a generic agent. You have to, of course, select the type of the agent, whether it's a service agent or a sales coach agent. But let's say once you selected service, you can define various topics. The challenge is that right now it still operates within the context of one single agent, right? Because you can create 10 topics within one agent. And the idea is that it would be more scalable and performant if you have specialized agent with only topics specific to their domain, so that you introduce a concept of separation of concern, right? Where only the agent who is supposed to do service task will act on that, because that will really optimize the maintenance part, the execution part of the agent, because the less the number of topics, the less an agent has to really plan, because the agent can quickly filter, oh, this is the prompt, does it match my topic? No, I'm not really the person to handle that. Okay, next one, right? And that agents, individual agents don't have to do. The supervisor, the manager agent will have that information that, oh, because this is for sales, let me directly go to sales. And sales guy will say, yeah, I mean, this is my area, I will do my best and quickly execute the task, return it, right? So it is going to improve the maintainability, the efficiency of the platform even further. Okay. And yeah, the quality as well.
It's also about skills.
Yeah.
So, see it as a team working on an implementation. That you have an architect, you have multiple developers, you have business analysts, you might have functional consultants, you might have testers, and the same principle applies here. So you can also have agents that operate within the same domain with a specific skill set. That one is a research agent and one works on writing a nice output. That you can also write like a long text. So it can really be skill focused or specialized knowledge.
Yeah.
And then when they iterate on that very narrow focus, their quality improves much more than if they iterate on everything together in a single agent.
Yeah.
Why wouldn't they put that thing in the Atlas reasoning engine? I mean, it would be part of orchestration, right?
Yeah, but the reasoning engine, you have to understand, right? It's powered by an LLM, and it takes processing and it runs those algorithms. So the more you kind of narrow the scope, the better the processing would be, right? So for example, another example is if there is a service agent has to access the knowledge article and get the policy data or whatever data from knowledge. Maybe sales doesn't, the agent doesn't have to, right? Because it's more about upselling and the new things or maybe the product data, and it's not an unstructured data, it's already in the product database as a structured. So now you don't really need to integrate RAG with the sales agent, but for service you have to do. Now every extra processing step, for example mixing RAG outcomes with the prompt, is gonna delay by some milliseconds, right? And add that milliseconds over the every day when the agent executes, it takes some time, right? So the idea is how you can create specialized agents and then kind of ensure that they collaborate with them, just like we operate in a team, right, within Scrum, where one guy focuses on one task another, and then they efficiently collaborate to deploy, right? So that's the idea. We'll talk more about that in few slides. Let's look at Agentforce 2.0. So now we have a fair understanding of the Agentforce architecture, what was done, how it operates from under the hood, right? Now Agentforce 2.0, these are the configuration attributes on the left, right, for Agentforce 2.0 agent, right? So and every agent has a purpose on your team. Like I said, service agent, sales agent. So you need to really, once you are actually creating an agent, right now, if you go to Salesforce, try to create an agent, you need to actually pick an agent and you need to define whether it's a service agent or a sales agent, right? Right now that distinction is already there, or an employee facing agent. So right, still the terminology Einstein Copilot is used to a certain extent, because Copilot type agent is an employee facing agent, which is only interacting with the users within the Salesforce platform, and that agent is not supposed to be deployed to end customers on a community or a WhatsApp or any omni-channel part, right? Now the second part is trusted data, right? The context an agent needs to work. So we'll talk about that. So trusted data, of course, is the topic, right? Like what are the different topics that person can handle, the agent can handle, the actions the agent can take. For example, can an agent update the case? Can an agent invoke a flow to update opportunity status to closed one, right, automatically without any human intervention? Or can an agent call a third party API, maybe a payments API to process the payment, right, on user behalf? There are many possibilities. Then the guardrails. So guardrails are created in Agentforce in form of instructions, and we'll talk about that in the next slide. But you need to ensure that your Agentforce agent is clear what the agent is supposed to do, but most importantly, what the agent is not supposed to do. Very, very important. And that has to be part of your instructions. For example, you need to tell the agent that you can query the case data, but you are not allowed to update the case status. That's an instruction. You are creating a guardrail that you're protecting your data. Because remember, it's when we are creating autonomous agent, the risk of an agent, updating the data or messing up something is even more, right? So we need to be very pragmatic that when we are creating agents, the guardrails are very clearly defined. And the channels then is the next one. Now you can actually deploy an agent on web, on mobile, on Slack, on WhatsApp. Now, let's look at the key features of Agentforce 2.0. Do you know if it is live or not? Anyone following the developments on Agentforce 2.0? No? It will be live in Feb 2025. So as we speak, should be available next month. I'm not sure if it's a safe harbor or not. I'm not. There are folks probably from Salesforce here who can confirm that. But no, at least I tried today because I was doing something and it's not there yet in the sandboxes. But should be released in Feb 2024, 25. Sorry, safe harbor again. Yeah, Agentforce anyways is not following the regular release pattern like Data Cloud. So these innovations will keep on coming without sticking to the regular release pattern.
Like with regular release.
With the Hyperforce, yes.
Yeah, but I mean, with agent for releases are happening at the same time for production and sandboxes.
Yeah. Okay. Yeah. From the yeah. There is nothing like first it will be available in sandbox and then production like the regular updates. Yeah, there are because what Salesforce is doing, and that's my understanding, is that they are of course pushing some new changes as part of the regular releases. That's always there. But then they can also release some features on another schedule. So, for example, with this Agentforce 2.0, they are releasing some new features in Feb 2025. This is on the Salesforce AI research. If you go to the Salesforce AI research.com, you get all the details that what is the roadmap, what's coming. Salesforce also announces it on their website. If you follow some blogs closely like Salesforce Ben, they are pretty proactive in also providing. Yeah, architect website. Exactly. Yeah. Yeah. Yeah, exactly. So
Checking the Salesforce that checking for Einstein on the web. Salesforce.
yeah,
Einstein credits are added.
that's the concept of safe harbor. Okay, so let's move on to the features. I think the first feature I would like to focus on is that in Agentforce 2.0, you will get a much more broader pre-built skills library. And like it was mentioning, the skill is nothing but what actions the agent can take. Uh, so this skill can an agent, for example, call a MuleSoft API for payment processing, like I mentioned. Can an agent, let's say, update the opportunity status? Can it generate an opportunity forecast? Right. So pre-built skills are not custom skills, but they are on platform actions which an agent can automatically take, right? And what Salesforce has done is they have built those actions, they have wrapped those in a wrapper, they call them skill. And now the only thing you have to do is that when you're creating an agent, you can pick and choose from that library of skills that what are the standard actions you would like to assign to your agent. No, not the pre-built one, because they are built in a certain way, but you can always generate your own custom actions on top of that. But yeah, probably. I don't know yet. I've not tried it because this feature is not yet available. But I don't think because even in the current shape, there are some pre-built actions and you cannot really tweak those or clone those uh, because they are built under, they are like part of managed package where you can see the prototype and everything, but you cannot actually tweak anything there. And I don't think even clone it so far, but it's probably a good idea to get the capability to clone them. The second one is enhanced reasoning engine, Atlas. It has been revamped, and we will talk about that, how the reasoning engine has changed and what was the reason, right? We'll talk. The RAG index also, when Agentforce was introduced, there was a particular way how you retrieve the data from your unstructured knowledge articles or files or documents. It has been enriched a lot. There are lots of innovation happening in RAG space. So I would say if you are focused on AI and not aware about RAG at the moment, I think it's time to really learn it, because there are lots of patterns emerging. Some of the patterns we will talk about briefly. Uh, Now let's look at the other one. You can deploy an agent within Slack. So Slack has got lots of updates. How many of you use Slack, by the way? Okay. I mean, in professional setup or personal? Professional. Oh, Taras, you use it professionally. Come on, you're Capgemini. For the client. Okay, good. Okay, cool. And what do you think about Slack? Anyone would like to give a feedback? No, but in general, right? What I'm interested in is that, of course, Salesforce is heavily focused on Slack. It's a really nice tool, but is it really being adopted a lot by the customers, or not? I'm curious. Sorry. Okay. Yeah, and I also feel Slack is way more flexible, way more open in terms of the APIs Slack provides, because now you might have seen some demos during the Word Tour. You can actually deploy an agent within Slack, and you there Salesforce actually created a very cool demo where you show the multi-agent interaction. So there is a sales agent within Slack, service agent, and they are talking with each other and collaborating on customers' request. So the use case was a customer reached out to a support agent saying, "Hey, I have an issue with my this product. Can you actually return it, because I don't need it?" And the support rep says, "Okay, let me check the policy." Checked it and said, "Oh, sorry, I can return it, but we don't have another size available," right? And then support rep says, maybe I can redirect you to a sales agent, and sales agent can recommend a similar product for which we might have the inventory. And then the sales agent gets the request. Actually, sales agent confirms that there is a similar product and the inventory is available. Then again it comes back to support agent. Support agent replies to customer saying, yes, for this product the inventory is available, would you like to go ahead, right? So that's all happening within Slack. Then there is something called agent testing center. uh, you're creating agents, but how do you test agents? And by testing, I'm not saying just writing one prompt and checking what's the outcome. That is already available there. But how can you scale test your agents, right? Like scale, like you send thousands of prompts to an agent and see if it's able to handle that. If the outcome is positive, fine. That is what agent testing center is bringing. Will it charge? Good question. No, I don't think so. The testing center is gonna incur that as long as you have this feature. And I'm not really sure if this will be an extra price part of that, because the details needs to be there. But architecturally, I know how they built it, and we'll see the sneak peek of that in the coming slides. Important question is that point is that when if you have to test it, you will of course test it in a sandbox, right? That's given. You built an agent in sandbox, you are gonna test it, and whatever you are going to do with your agents in sandbox, and if it invokes LLM and all those conversations, it's going to charge your credit. So could be the testing center also has some fixed credits per batch of the test you will run. But that's important about data cloud and agent as well, that if even if on the sandbox you're going to consume your credits. So that's how it is. Yes. Now it's charged. Yeah. That's what I'm saying. Both Agentforce and Data Cloud is chargeable in Sandbox. Yeah, definitely. Yeah. Yeah. I think the only thing which you need to ensure is that your agent at least is not hallucinating. It's stable. Then you take it to production. Maybe release it in an open in a closed pilot, right? And then before rolling it out to all the users, we'll talk about that rollout approach as well. But yeah, testing natural language agent building. Imagine you want you to just say, oh, write a prompt saying, hey, I need an agent. It should be a support agent and it can do this stuff. And Agentforce creates an agent for you by selecting the right actions, right topics, everything. That is natural language agent building. We all have to see how it works practically, but this is something which is being released. So imagine you don't even have to actually learn the sequence of the steps required to create an agent. Platform will create an agent for you. Super powerful. MuleSoft integration and API catalog. I told you about it. There is a lots coming on the MuleSoft side. I'm actually most excited about this feature because it will open up the capabilities of an agent for those third-party integration, collaboration, and your agent force metadata the topics, some metadata will be visible within the MuleSoft connection as well, where you're creating your MuleSoft flow. So there is some tight integration coming in that space. Then you will have greater customization capabilities. Again, custom actions and some other, you can create branded set of agents. So for example, you need to create an avatar of your agent, which you need to deploy on your customer facing community website or whatever. You can do that now because right now the agents are not branded. And the last one is Tableau skills and analytics, greater integration with Tableau, usage of Tableau for running reports or generating reports, on the agent skills and the overall insights on how agent is working. So that's about Agentforce 2.0. This is just one slide which I've captured actually in the previous slide a subset of the key features, but if you look at it, there are many more, right? Tableau semantics. They are also saying Agentforce voice, by the way. So which means that you probably would be receiving Agentforce voice capability, right? Where you can actually talk to an agent and agent should be able to process it. Well, I think that will happen. There are already solutions available in the market. So let's see. Another important one is field service scheduling. That's important, right? Agent can schedule an appointment and use a field service solution. Uh, Inline citation is very important. How many of you use Perplexity, by the way? Use it? Okay. Only two of you? Okay. Oh, okay. Cool. Yeah, Perplexity is like the search engine, AI based search engine, just like Google. But Perplexity, what it does is it actually looks at the top 10. So let's say if you ask Perplexity, give me the agent force architecture details, and it will scan the top 10 links. So in Google, what happens is you search for it, you get like a list of links, and it's up to you to click every link, get the details. What Perplexity does is it actually scans the different links, the top ranked links, and summarizes the details, extracts the details from them, and gives you the summary. So basically, it's a search AI based search summary solutions. You don't have to really click on one individual link. Uh, but what another thing Perplexity does is that when it generates that LLM based response, that it says, okay, agent force architecture, Atlas reasoning engine, enriched RAG index. It also gives you a small inline citation saying, I generated this outcome based upon this link. So you can actually verify by clicking that link that how this information was generated by LLM, right? So it's not black box. You can actually go to the source of that article and see that. That's inline citation, and that is what Agentforce also is planning to do. That when a customer or an employee will get outcomes from Agentforce, there will be some inline citation. So, for example, you can actually see that this response was generated based upon this knowledge article with this policy, right? So there is a transparency, less risk of hallucination, right? So because if you know the source, you will be more sure that that will generate more trust. Okay, now let's look at Atlas Reasoning Engine, fast and slow. That's what I've written. So this is a very nice overview of what is done to enhance Atlas Reasoning Engine. Okay, let me ask you a question, right? I'll try to simplify it. If I say, okay, agent, can you give me a summary or details of case number 1, 2, 3, 4, 5? Do you think it's a complex question or like a simple query or simple prompt? Sorry, simple? Yeah, it's a simple one, right? Like what the agent has to do is, this is the case number, get the case record, and standard action, get record, put the case number, and it will get the details of the case. Okay, who is the case owner, case description, case status, blah blah blah. Simple query. Now there could be another question to this, that can you give me the return policy for the product number blah 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 with description this and this. It could be a 5-line question with saying that, okay, can you give me the return policy, can you also process the return in the same question. Now that's a complex prompt, right? Now what Salesforce did is, Salesforce has decided that we will not treat all the prompts in the similar fashion. So if there is an easy question, so it's also like that. If there is an easy requirement to be built on a team, give it to junior developer. If it is a complex requirement, give it to the lead dev who knows Apex, who can code and blah blah blah. Because junior dev doesn't write Apex. Maybe junior dev can configure Flow, right? Like so, this is how now Salesforce has divided this into two types of response style. One is system one, and then another one is system 2. They call it system 1 inference and system 2 inference. So system 1 is, for example, in this case, the question asked is, what is the current balance of Emma's portfolio, right? It's a very simple request. You need to understand, okay, who is Emma? Maybe it's a person account in Salesforce, and Emma's portfolio value is somewhere summarized already, and the agent has to fetch it and says, oh, Emma seems to be super rich, it comes around 1 million or something, but yeah, that's the portfolio value. But then system 2 inference is where you ask, okay, does Lauren's portfolio have any hidden risks due to rising interest rate on fixed income and interest sensitive assets? So imagine, first you need to identify, okay, Lauren's portfolio. Then you need to identify the hidden risks due to rising interest rate on the fixed income and different assets. Now, this is a complex query for agent or any agent, right? Because you have to first understand what are the assets, what is the investment portfolio of Lauren. Okay, there is a bond fund, there is a real estate fund, there is a utility income fund. These funds are susceptible to these type of risks due to rising interest for the following reasons. Recommended mitigation strategies, right? So this is a much broader response. Now, so the idea is that look at the prompt or the question which an agent gets. If it qualifies for system 1, which is a simple type of inference, don't spend too much time and don't go to that advanced path. So think of it as that within the reasoning engine, they have created a decision path by saying, is the request complex or not? If it is simple, take this path, run a quick action, get the outcome without involving in too much of deep reasoning, planning and other stuff. If the request is complex, then take another path and then process it and go to the deep reasoning, right? And that's why I called it fast and slow, because what Salesforce is trying to do is that they have identified that not all the responses needs that detailed level of reasoning and planning. So why to take the same processing time for each type of request? Because if it is a simple request, it needs to be processed in a fast manner and the outcome should be there. While for the complex request, it makes sense to take time, reason it out, iterate it multiple times, and then give the request, because then you will give the most accurate response to the user. And this is a very sensitive response in terms of, because they're trying to identify how the future portfolio investment should look like. So it needs to be thought through. You cannot just process it like in milliseconds, right? So that is what reasoning engine right now is doing. So they have system 1 and system 2 types of inference, and reasoning engine tries to split it based upon the complexity of the request. So that is one of the major advancement, and that's why now it's called enhanced Atlas reasoning engine compared to just the reasoning engine. Now, these are the underlying mechanics. I would like to give credit to my colleagues in Capgemini, Germany. So they created this slide, but I wanted to create a similar one, but let's not reinvent the wheel. I think they have done a great job. So I used it with their consent. So if you look at it, this is how the reasoning engine works, right? I hope it is visible to all. Is it visible? Or okay? So you have a user writing a query. Why is the light on my RoboVac Series 7 blinking? That is the question user asked. Agent says I'm on it. Now agent takes processes. This is the Atlas reasoning engine part. So first the intent detection will be discovered. Understand the intention. So what is intent detection? This is where the actual topic of the agent is identified. What is the user trying to do? It looks like a topic where the user needs support on a product or something. So it's intent detection. Then processing. So basically, once the topic is identified, then start processing. So where the actions, instructions, all those guardrails are kind of followed. Then the planning happens. So let's say based on the topic, there are 3 actions identified. So planning and orchestration is which action will be executed in which sequence to support or provide resolution to this query. And then the agent Atlas reasoning engine devises a strategy based upon whether it is task based or job based, and then invoke action. And within action as well would be a combination of standard and custom actions, right, which are assigned to the topic. And of course, Atlas reasoning engine has a short term and a long term memory to maintain the context of the conversation, right? And as you can see here, there is a RAG integration as also mentioned, right? So you have a data cloud, you have a data lake object, then you actually chunk the unstructured information maybe in documents and put that in chunk. You create vector embeddings of that, and then you put that in vector database, which is used by the reasoning engine if a RAG is required, right, as part of that request. So this is how the reasoning engine is architected behind the scenes, right? And then and I think if you see, I think Agentforce 3.0 is also on the roadmap. The rumor I have heard is that will be available in May 2025. But again, safe harbor. I'm not representing Salesforce, so I don't know. But there will be further advancements, right? You have to do it, right? So I mean, about DeepSeek. Yeah, 2 days back, what happened to Nvidia stock? So it's changing. AI, it's this space is evolving very rapidly. Yes, please. No, it will be seamless. Yeah, compatible. Yeah. Uh, good question. I don't think so. Well, I think right now you can link it to 3 types of models, right? One is Salesforce hosted, so which is hosted by Salesforce. Another one is Salesforce managed, which is not really hosted within the VPC or within the secure parameter of security parameter of Salesforce, but still managed by Salesforce. Third one is where Salesforce has agreements, for example, OpenAI models, right? So these are the three types of models available. I think DeepSeek will take some time. Considering Salesforce is an American company, I don't see that Chinese model integration with the Salesforce happening too soon. Yeah, but yeah, definitely. But I think it will. There are too many suspicions right now, regarding the claims of that model. For example, how much money was spent on training that model, and how, So I think it will take some time to build some trust. Some people are saying it's, really good. They have published a white paper. Everything is transparent, and some are saying not all the details are similar. So I think it's too early to comment on that. But if what they are claiming is true, it's going to change the way AI models are, this industry is evolving. Because then the world will understand that you don't need nuclear power based data centers or to power those GPUs for running or training those models. The energy requirements are too less if the Chinese model can perform better. And then, of course, you don't have to spend billions on training the model. It can be cheaper as well. But let's see. Okay, let's this is another slide, a more detailed architecture slide. This is how Salesforce is looking at the next steps of Agentforce architecture. Again, for folks who are working on the platform, probably you might think, oh, why do I need this, right? I just need to learn how Agentforce works, and that's it. Who cares about whether there's a event-driven, interaction happening under the hood? The I think if you are into a consulting space or even Salesforce, right, and you're interacting with customers, there are two types of customers. And this question was asked to me by one of my colleagues. There is one type of customer who don't know anything. They want to try AI with Salesforce Agentforce. They don't care what capabilities are offered, what is the under the hood architecture, what algorithms are being used, as long as their business cases are served. Then there are another type of customers who are investing a lot in their own AI initiatives. They have AI experts in-house. And if you're interacting with them, you need to know the details, right? Because you cannot just say, oh, this is Agentforce. It is solution to all your problems, all your issues. Please implement it. Problem solved. They will ask you questions about, okay, well, how the processing happens, if how the complex queries are processed, which algorithm, what if I don't want to use React but something else? Don't you think it will bring more benefits? How will you answer those questions if you don't know what is being used under the hood? I think with this platform driven AI approach, I think Salesforce is offering lots of benefits, right? Because you don't care about the model hosting. You don't care about the underlying infrastructure, which foundational model, anything. You don't have to code in Python, nothing, right? Compared to if you have to build an agent, let's say with LangGraph, in an open source format, you have to do lots of things. Right? You are where to set up vector database. Salesforce is offering everything out of the box, but with every package, the limitation is that you have to stick to what they have built under the hood. You cannot just say, okay, change React to chain of thoughts or something else, right? And I'm not saying it's a bad thing, but you need to know that, and you need to know that what are the differentiators there. If there is a React, it's not bad as long as you can convince your customers that it does the job. It takes care of that. Yes, there might be some advanced algorithms, but for your use cases, this is the perfect fit, right? But if you don't know that, it's very difficult to have those deep conversations. This is the cognitive architecture, right? How eventually Agentforce the Atlas engine is gonna communicate, right? So there are different ways in which an agent can communicate with different apps. So for example, if an agent you have created has to integrate or call Google Calendar, right? So let's say you say, hey, can you please create an appointment for this event on this date on my Google Calendar? So what an agent needs to do, agent needs to have access to the Google Calendar of this device. That's number one. Number two, agent needs to send some sort of communication to Google Calendar, right? The parameters. What is the event date? What time? Duration, blah, blah, blah. So there are two ways to do that, or maybe three. Either Google calendar gives you an API which an agent can consume and send the data. There is another thing called function call where Google Calendar also kinds of acts as an agent in itself, and you can have a function. So how many of you know about function, right? It's a typical common thing, how you interact. So basically sending a message to another party and with some parameters, so it's like if it would be a function call, the parameter would be event date, event time, right? And then the Google Calendar will accept it. The third way is if you can send an event, and I'm not talking about platform event, but just an async event, asynchronous event, right? What Agentforce Atlas engine is planning to do, or how the architecture will evolve is there will be an event-driven graph of communication which will be created to communicate between different agents on Salesforce platform, but also cross-platform, right? How the communication protocol cross-platform will evolve, that we need to see, right? Because if you have to communicate with someone, you need to establish a standard, right? So you are driving on the road, you need to take a left turn, you need to give an indicator. That's a standard, that you're taking a left turn, you need to give an indicator. There is a shark tooth towards you, you need to stop, someone needs to pass, right? This is the standard communication of traffic rules, the protocols. Similarly, if cross-party agents have to communicate, you need to create standards. But can those standards or the communication be synchronous or asynchronous? That's the question. And what Atlas, at least the thought process or the roadmap is that it will be an async event-driven graph-based communication. So if you see here, there is a start event, and then it actually goes to an orchestrator event. Orchestrator event is nothing but a manager, a supervisor event. It invokes the orchestrator. Orchestrator is a manager agent or supervisor agent, which first handles the request, and then it kinds of distribute the request to other agents on the platform, to YouTube, to general search, to finance agent, to other agents. But all is happening in an async manner. You cannot afford to do a synchronous communication of such sort because then it won't scale. What is the limitation of a synchronous communication? Anyone knows? Like in general, if you send a message to someone in a sync way, yeah. Basically, the challenge with synchronous is that if you are sending a message, you're waiting for the response. Till then, you can't do anything else, right? That's synchronous. You need a real-time response for your request. But if you look at this architecture or how the agent force is going to evolve or the different agents can communicate, do you think it will scale if all agents start sending each other synchronous requests and keep on waiting for the response? No, it never would happen, right? So the only way to do is send a request, let the other agent take care of the request. Once the other agent is ready, send a response event saying, hey, I've done my job, I'm ready. It's just like you're assigning a task to your team member on Teams and saying that, okay, whenever you are done, just shout, just let me know, just ping me. You are not really constantly watching that team member unless you are a micromanager really trying to see what that guy is doing. You trust that guy will do. So this is how this will evolve. So this is a sneak peek. This graph is actually from a very nice Salesforce engineering blog written by SVP or VP on the Agentforce AI platform. And I would encourage you to read that. But it talks about how the agentic communication is going to evolve. But as it stands, it's going to be event-driven graph. Yes. Yes. So Actually, there are three. Now you have asked this question. I was about to cover that in subsequent slides. The three patterns, right? Let's look at it very quickly. Number one is an individual agent. Right now, Agentforce is current shape. You create an individual agent, you define topics, it takes care of the request. The second level or the future of that is that you will create a manager or an orchestrator agent, and it's gonna take care of offloading the request or assigning the request to domain specific or specialized agents. But it's all on Salesforce platform, right? So we are not going outside Salesforce platform. So what we are saying is you will create a supervisor agent on Salesforce platform. All the requests will go to supervisor. Supervisor's only job is to identify the right agent for the right job, assign the task, and that agent will do the job, get back to the supervisor. Supervisor will say, tell the user that this is the response, right? The third pattern is going to be that, okay, this is still Salesforce platform, but what if you have a community of agents like an agent exchange where you have Microsoft Dynamics, let's say Microsoft platform, they have their own set of agents. You have Salesforce as a CRM, it has its own set of agents. There is some other platform, ServiceNow, that has its own set of agent. How a Salesforce agent can communicate with the ServiceNow agent, right? So that is the third layer, right? Where we are saying cross-platform agenting communication, right? So what we are, the idea is that it will evolve from a single agent to the orchestrator pattern, uh, still on the platform. Then we will start moving towards cross-platform communication. And the idea is that the only way you can scale this whole architecture is if you work in an async event-driven graph kind of patterns, right? Rather than sending real-time synchronous API calls, because that will slow down really the processing, because you cannot keep on waiting for all those individual agents to really complete their task, and come back and within a certain time frame and keep the user hanging, right? It's very as simple as that. Okay. Well, this is again a very advanced architecture of the RAG index. So what has been done in Agentforce 2.0 is that the RAG architecture has been enhanced. And why it has been enhanced is because the current RAG architecture doesn't really support the processing or the kind of retrieval you would need to from millions of documents, right? Again, to ensure that the processing is fast, it's more scalable. Uh, so what has been done now is that that's why I'm saying, have coffee during the break, because you would have to see these kind of diagrams. They're much more complex, but I will try to simplify. That's my job as a presenter today, as much as possible. But bear with me, right? So right now, what is happening is very simple. If you have a document, let's say knowledge article, you create a RAG index on that. What it does is, okay, let's say you have a 2 pages of document knowledge article of your customer support policy. When you create a RAG index on that, what it does it breaks that document into individual chunks, right? So let's say first four word of the sentence, one chunk of the RAG index. Then the next four. So you have different division, content division strategy, right? Which we call chunking strategy. You can divide the document into different chunks by sentences, by some words, by paragraphs. So there are different chunking strategies. So it does that. It breaks that into chunks. And then when you ask for a company return policy, agent tries to match your query. For example, this product's return policy tries to identify the chunk from that knowledge article which closely resembles that return policy, and then kind of gets the details that, okay, for this type of product the return policy is 30 days because that has been written in knowledge article. So far all fine, right? But what if you want to, if you have a query where, for example, earlier we saw where it says, uh, can you tell me some of the strategies to change my investment portfolio if my portfolio amount is $1 million? Let's say that is the question. Now, first of all, agent needs to understand what is portfolio amount. Is it a field on a person account record or a account record of the customer? What is a portfolio amount, right? Maybe it's a summarized field, it's like a roll up hierarchy, kind of roll up summary field on a person account, right? Which actually looks at all the assets, records of the customer, sums it up and says your total portfolio amount is $1 million. But how will agent know that we are talking about that particular field on the person account record? There is no way. So basically now you see, right, the complexity. So you need to know the portfolio. First of all, agent needs to understand what is the query. The query is, can you tell me the risk strategies if my portfolio or the investment portfolio reallocation strategy if my portfolio amount is $1 million. So the agent first needs to understand, okay, it is talking about portfolio reallocation strategy. It probably the reallocation strategies are documented in my knowledge base as a knowledge article. So maybe I need to do a RAG on that. Okay, but how will my knowledge article, it understands that what is portfolio amount, from where can I compare that this customer portfolio amount is $1 million, right? Like, because portfolio amount is a custom field you have created on an object. So what you need to do is you need to mix and match the metadata of Salesforce platform, which is your field on an object, with the chunks of knowledge which you have created on your RAG index, right? And that is what we call multi-round indexing. So what Salesforce has done is there is a concept called metadata extraction. So this is the whole RAG index architecture. Salesforce has implemented some new techniques where the metadata, whatever custom fields you have created, whatever standard fields are there, whatever objects are there, all the metadata is kind of extracted and embedded in the chunks from of your unstructured data of your organization, so that if an agent gets this request, agent can easily correlate that, okay, this portfolio amount actually lies in that chunk of the sentence, and this is the portfolio amount, platform, sorry, investment portfolio risk allocation strategy. Does that make sense, or not yet? Yes, please. Yeah, but it also ingests those along with the chunks and the embedding you create. Because the output, if you see, is that you do a metadata extraction via AI inference library, then you generate something called embedded generation, and then the outcome that is metadata and question chunks together, so that there is a correlation metadata and the chunks which are created. So that is multi-round indexing. And then there is something called dynamic context aware retrieval. So what it is doing is that there is a dynamic retriever which has been created. So when an agent has to extract the information from RAG, it has to, there is a concept called retriever. It's called search index retriever, which is created. And now Salesforce has also enhanced it so that, if let's say your question is, what is my risk allocation or, portfolio allocation strategy, considering my portfolio amount is 1 million, considering the risks. Now, maybe, if you rewrite that question, rewrite the query, it will be able to extract more details from your RAG index. That is what the dynamic part is. So what it does is it can also, there is an augmented retriever, which will try to actually get the first level of RAG data from your knowledge base. But then if it is not satisfied with the result, there is some concept called query expansion. With that, you can rewrite the query using the of LLM, the models, and then write that in a more expanded way so that the results are more accurate, right? So these are more architectural enhancements again, but again, if you are, yes, please go ahead. Yeah.
The way you use it is that you have a prompt template and you say, and you input all merge fields there. So if
True.
that is a query, get the details of this customer from this record of these fields or
exactly.
with this metadata augmentation, will it eliminate this need of
No.
using merge fields?
Mhm.
Will,
Yeah.
I mean, why would I need this augmentation? Because in my prompt template, I already I eliminate this part of when the model needs to find out where this data is
Exactly. No, very good question. So let me answer that. The first of all is that you won't use prompt template always. So that's the first thing, right? Because your actions, the prompt template comes into picture when your action type is of type prompt, right? So let's say if you ask, can you give me the portfolio allocation strategy if my risk portfolio or my portfolio amount is $1 million? If the action assigned to that topic is not a prompt one, it will never come into picture. It could be an Apex action, it could be a flow action, it could be a MuleSoft API action. Prompt builder, prompt template comes into picture if you have an action assigned to that topic with prompt. Now, still, let's say the action is a prompt type, right? So basically, if such a query exists, there has to be a prompt that needs to be sent to LLM and the response needs to be generated. Now, prompt template has two things. One is the merge field, right, where you write the instruction saying if this is this portfolio amount, merge field is this. But what we are talking about here is that merge field is directly used as a value, not as a metadata. So when you embed a merge field in the prompt template, it simply replaces that with the value. So when you say portfolio amount, it will just replace it with $1 million. It will never say this is the prompt, basically the API name, right? API name is embedded in the prompt template, but in the runtime, it is replaced with the value of that field. But where that metadata is more important is the RAG extraction part, which is different, right? Because the prompt is sent to LLM, but before that, the prompt is enriched with all the information you are getting from a RAG index, right? And for RAG index, it's very important to know which portfolio amount are we talking about. Because RAG has something called, maybe in the RAG knowledge base, there is something called asset amount or total asset amount of the customer as $1 million. Now you need to correlate that portfolio amount in your custom field, which is your custom field, actually maps to the total asset amount which is in your RAG index, right, in your policy. And that correlation is the metadata extraction, where you're kind of augmenting, enriching your chunks with the metadata descriptions, right? And then you come back and say that, okay, based upon this portfolio amount, this is the policy. You augment, enrich your prompt, then send it to LLM, and then LLM will give you a more detailed response based on. Exactly. More relevant chunks and with based upon your organization's metadata or database structure, right? So that's important. And then the retriever is augmented so that it can do query. Basically, the end goal is same: get more accurate results based upon RAG index with these architectural enhancements. Okay, but it's probably too deep, but important to understand that because the RAG, this is more simplified view than that diagram. So again, my colleagues from Capgemini Germany created this very nice view. So I didn't want to really reinvent the wheel. But again, if you see here, this part we covered: user query. This is query evaluator, content refinement planner is Atlas reasoning engine. This is where the RAG index comes into picture, right? Data index. So there are different techniques now Salesforce has introduced. It's called chunk optimization, where you split the chunks by their semantic meaning. So what do I mean by semantic meaning is that if the meaning of the query and the text in semantic terms matches, right, rather than literal keyword meanings, then you can split the chunks into that, optimize it. Multi-representation indexing. What do I mean by multi-representation indexing is that RAG right now is creating, so let's say there is a knowledge article. It is creating 5 level of summary of that knowledge article. One with some summarization of, let's say, 400 words, another one with the more enriched summary or a more descriptive summary of 300 words, 200 words. And it is creating summarization at different levels for, again, the efficient processing. So that summary is very important, because if you convert your large millions of documents or thousands of documents into a summarized version, it will be easy to retrieve the data very quickly, right? Then there are some special embeddings, and then there is something called Raptor. I'll not go into the details, but it is a hierarchical indexing form of that. So all these techniques are being used, and again, these are also being used in open source world, right? Not only in Agentforce, and there are different architectures emerging for that. The whole idea is process fast, retrieve the data efficiently, and most importantly, more accurately, right? Let's not spend too much time on that, but again, key features of this is, like I mentioned, multi-indexing. There is a fallback mechanism also introduced. What if you are not able to retrieve the right result using your RAG index, or it errors out, or it doesn't provide you the right result? Then what is plan B in that case? So there are certain mechanisms, with these new architecture, it has been made more scalable. And a concept of parallel processing has been introduced, because imagine if you have millions of documents, and if you try to query something from those millions of documents, you need very efficient processing, and you need an architecture that can parallelly process that information, right? And that's why all these techniques have been implemented, right? Because some of the enterprises have millions of documents. So let's look at more simple thing before we move on. So there is a RAG pipeline and there is an agentic RAG pipeline. Why Salesforce kind of improved the RAG indexing is because Salesforce is moving towards or agentic RAG. And what is the difference is that between RAG and agentic RAG is that in RAG pipeline, there is a query, there is a retrieval. After retrieval, you do the re-ranking of the outcomes, and then you generate and answer it. Simple, one step sequential RAG pipeline. In agentic RAG, which is now with Agentforce 2.0 has been made or introduced, is that first the query is analyzed to ensure that is the query complete, do we need a query expansion or enriched. Then you do the retrieval, then you grade the retrieval, then you rewrite the query. So maybe based upon the initial query, the outcome was not very accurate, so you will have to rewrite the query and then again retrieve it, and you have to keep on doing it till you get the right answer, right? That is agentic RAG. That is, again, very important from a RAG point of view, the same like reasoning engine, because if you don't iterate over the first set of the results, there are high chances that you will probably introduce some error into the agentic RAG schema as well. So so that's why agentic RAG is more about query analysis, query rewrite, dynamic retriever, enriching with metadata, and making it more accurate, more efficient. But the only risk here is that, as you can see, this is a very simple processing, and this is much more compute intensive processing. So how can you build an architecture which actually processes it in a more optimal way? And that is what Salesforce has done. Yeah. It's powered again by LLM. Yes. Yeah. No, that is what. And the reason I'm explaining this to you is that many customers, they have such requirements, right? So when you talk about, okay, we have an enriched RAG index and this is the agentic pipeline, and if someone knows the agentic pipeline patterns, they would ask you whether it's knowledge graph, whether it is Raptor index, or whether it is this. Because, for example, a customer can say, hey, I need an agentic pipeline with knowledge graph. Does Agentforce offer it out of box? What would you answer as a Salesforce architect? I mean, you can always reach out to solution engineers. We have some sitting in the room, but and they can find out, but you need to know, right? Like how the patterns are emerging and what are the limitations, right? Because I'm still saying Salesforce has done a lot of improvements, but there are few things still missing, right? And there are certain architectural decisions they have taken with this, which is fine because they need to create a fine balance with the compute as well. Because if you build the best agentic RAG pipeline, let's say, but it is taking a lot of time to process, it's not scalable, it is timing out sometimes, then it doesn't help, right? So Salesforce has done lots of architectural innovations, have used AWS SageMaker in inferencing techniques, have worked with AWS on improving some of the stuff, not only for RAG but in general for Agentforce for some of the stuff to come up with this architecture. But still, you cannot satisfy everyone, right? Will be still some use cases where this will not be enough, right? So we need to be aware about it. Yes. Yeah. So again, that is baked in the LLM quality gate, right? Where there is a semantic similarity which you have to establish between what is being queried and what is the response. Till that semantic similarity threshold has not been reached, let's say based on the outcome, it will keep on trying to search. And then once it's satisfied that these parameter, these thresholds have been reached, then it will say, okay, this is 80% accurate, let me give it back, right? So those, again, the challenge is that if you're building it yourself, you can build it yourself, right? You go for single store Cosmos DB on Azure and you can build this RAG pipeline yourself. You have all the controls. You can build your thresholds and everything, and all fine. With platform like Agentforce, they have encapsulated lots of complexity behind this, because you don't need to understand if this is happening, but you don't even have control over those thresholds or parameters, right? And maybe there are certain, if you're working for a large enterprise customer, maybe this will not scale, and then probably you will collaborate with Salesforce, but at least you need to know what is happening under the hood, right? Maybe the Raptor index which Salesforce has introduced is not really the best solution for that kind of thing, and we need knowledge graphs. Yeah. Mm-hmm.
Database, those are mentioned as bytes.
Yeah. Yeah, exactly. That's semantic. Yeah, because the regular, so there are two again ways for search, or maybe more, but in general two. One is semantic search, and another one is keyword search. So the regular RAG pipeline could be simple keyword search, where you just say aeroplane, and it will just try to search for aeroplane. It will never try to search for flight, because semantically flights and aeroplanes are similar. But it will just try to search for aeroplane keyword, and if whatever is the matches, it will result. Now, Salesforce has also understood that maybe in certain scenarios, keyword search is better. So Salesforce created something called hybrid search, which is a combination of semantic and keyword search. So whenever this query is input, Salesforce tries to fetch all the results based upon semantic search as well as keyword search, then re-rank it, rewrite it, and then decides which one is more semantically or meets the threshold, and then it responds. Yes. Sorry.
You were saying that like
Yes. Yeah, exactly. Yeah, this is linked, right? Because you have just seen one agentic RAG pipeline pattern, and Salesforce, for example, have used Raptor indexing and hierarchical indexing. Now, there is another concept which is called CAG. So RAG, I will not explain that. CAG is cache augmented generation. So what if you can put some of the outcomes of your RAG vector database into a cache layer, and so that next time if a similar query comes, you can retrieve it from the cache rather than again processing the full RAG pipeline. It will speed up the process, but there are many people who say that this can lead to more errors because the data in the cache can be stale, right? So it is a fine balance between speed, efficiency, and that. But that pattern is also emerging. Some people are in support of that. Again, in the open source AI world, some are not, right? So Salesforce has not introduced a cache augmented generation right now in the current setup. But what is missing right now in Salesforce is enhanced reasoning or the RAG index is knowledge graph. So how many of you know data cloud? You know data graphs in data cloud, right? Of course. So data graph is a very efficient way of retrieving the data from millions of records by traversing the node the data very quickly. Similarly, in the RAG word, there is a concept called knowledge graph where you create a relationship between different chunks of data in terms of nodes, and then it's very easy to quickly process that. Salesforce did try to experiment with this. There is an engineering blog on that. You can read that as well. But the infrastructure which was put in place, it was causing lots of performance issues. And then Salesforce made a conscious choice that they would like to stick with the Raptor indexes, which is more hierarchical, structuring of the data compared to the knowledge graphs. Now, will there be any use cases where knowledge graph would have been more useful? We don't know, because Salesforce claim, at least from that engineering blog, is that Raptor indexes also kind of provide the same level of performance, but with the less compute intensive architecture. But we need to see that, right? But again, this pattern is also very popular. So again, if you go to a customer, they know what they're doing on AI, and if you can talk about that, okay, what Salesforce has a RAG, probably they can ask you the question, does it support knowledge graph or hierarchical indexing? And you need to answer, right? I mean, I would say so. As a Salesforce architect, we need to be curious what is happening behind the scene, right? Otherwise, otherwise you will have to depend upon product team. But yeah, it's I think because these patterns are way more important in the open source AI world. So if you ask someone who is working on LangGraph, LangChain, those open source agent building platforms, they know these things by like this. If you ask about knowledge graph, yes. Agentic RAG pipeline, yes. They know they have to build it from scratch. We are kind of spoiled in the sense, or we are blessed in the sense that Salesforce offers, builds a very nice platform for us. Salesforce is a very nice AI research team, very strong engineering setup, right? So they take care of all the complexity and give us such nice capabilities. But again, maybe if you know these things, you can have a very more knowledgeable or more useful conversation with some customers or their architects, and then you can also help Salesforce by providing the right feedback. If you're a partner, that maybe you can also try knowledge graphs, because we tried hierarchical indexing, because Salesforce is always open to feedback, right? That's the most important part about Salesforce as a company. They listen to the partner customers, so it's also our responsibility to provide the right feedback, and it's a collective responsibility to improve this platform, right? All right. How to build effective agents on Agentforce? How many of you have built an agent, by the way, so far? Okay, well, quite a few folks. Any best practices or bottlenecks you saw so far? No? Okay. What is the most important thing if you have to build an agent? Like, in your opinion, maybe one of you, because we are short of time, so need to move fast. Most important, anyone? Purpose? Okay. Anyone else? That's given. Uh, Data, of course, is the lifeline. I think the most important thing is, right, if you are building an agent on the platform, it's earlier it used to be, whenever we say building, it's the perception of the build is configuration or coding, right? That's how we link build to that. Now the roles have changed, right? AI or agent will take care of calling the actions. You still may need to write Apex or Flow for the actions, but the core stuff will be handled by agents. When to call an Apex, when to call and Flow with actions, and the reasoning and all. The most important aspect, of course, apart from data, which is given, is what are the guardrails? What are the instructions you are giving to your agent? That is very important. It is a make or break deal, and you will not, trust me, if you're building an agent, first time it will never come right. There will always be a problem. There will always be some scenario, some guardrails which will be missing. It could be as simple as give me the response and use this date format, MMDDYY. And then if you are missing that instruction and your outcome contains a date, the format could be off. It could be raw date format, right? So the instructions are very important, and telling the agent what not to do. It's not about what to do. It's like, because those are autonomous agents. So you need to teach your agents that, hey agent, you are only allowed to do this stuff. Don't mess up with my data. Don't, really overpower anything, right? So those classification, those guardrails are very important. So this is the flow steps I have created, in my opinion, right, which are very important. The first step is, of course, you click on create a new agent. You need to choose. Now you can create custom agent as well. Till the previous release, it was only 2 types, sales, service, or I think by default, the Copilot agent is already there. Then you define some agent setting. Uh, you need to define something called agent user, because agent will run in that context, and your company, what your company, what is the domain of your company, what it does, what is the description, right? All those things are important to define. Then you need to review those predefined skills, because before creating any custom actions, check if there are any standard action or previously created custom actions which are already predefined. And now with Agentforce 2.0, there will be many predefined actions or topics. Are they already available, and can you use that? And then there is a concept in Salesforce called agent data library. Earlier, it used to be called Einstein data library. It is a more point and click way of creating a RAG index. So rather than going to data cloud and then creating a search index, a RAG index by picking and choosing different parameters, Salesforce has provided you 2 options. If you have knowledge article, go to the Einstein data library, define, that these are the knowledge article, this is the object, create a search index. It will automatically take care of some of the deep configurations for you, and create a RAG index, and then create a retriever for that for you. It's kind of not a very known feature right now, but it's very, very powerful in the sense, because even if you don't have the documents in files, you want to build a RAG index on that, you can do that with data library. A very cool feature. Do explore that and you can link it right within the workflow of creating an agent, right? And once that is done, then you need to define some new topics, because maybe the predefined topics are not really helping. You need to define their scope. What is this topic about, right? What is the scope? So again, topics are all about narrowing down the scope, right? That this topic is about this, area. That's it. And actions will be also. Then you have to create actions, right? And action instructions are very important. Again, in natural language, right? So if you see here, there is no coding, no configuration here. It's all about defining and giving instructions, giving descriptions, right? That's the most important thing. That's why I think it's very important for us to learn prompt engineering, how to give natural language instructions to AI. It's a skill. Trust me, it's gonna be the new skill rather than writing Apex. If you can tell AI to do the job for you in a most efficient way, that is the skill of 2025, right? And it takes some practice. I have built quite a few agents. I will not claim 100, because Agentforce is very new, but this is the most important lesson learned. Then select the relevant prompt template. So if the action is based on prompt, then you need to create a prompt template, as you were asking. It's very important to also give or write very clear instructions on the prompt template, because the prompt is going to send your data from the merge field from other to an LLM. It could be an OpenAI, Salesforce managed LLM, or other LLM. So you don't want to really send some data which you don't really want to share with that LLM. So you need to write that instruction, and that prompt template is also a very key component, because that actually really defines the outcome of the LLM response. If you write it with the right instruction, right structure, your LLM response will be perfect. The moment you miss out on some key instructions, LLM will hallucinate. Trust me, Very, very important thing. And and after that, selecting the right LLM is also important, because if you're defining a prompt template, you need to link an LLM with that. Now, how do you identify that which LLM you want to use? There are LLMs from Cloud E, then your LLMs from OpenAI. There could be bring your own model LLMs. When to use which LLM? What is the difference between an LLM offered by Cloud? What is the difference between OpenAI, right? You need to know as an AI consultant that what is the what are the key features or pros and cons of some LLM. Then if you have not created an Einstein data library RAG index, you can create again yourself. Go to Data Cloud, create a RAG index. The benefit of this would be is that you will have more control over the chunking strategy. Yes.
Yeah, you mentioned Atlas, the model selection and different types.
No, because the Atlas reasoning engine is powered by something called large action model. It's a LLM which is trained on Salesforce specific actions. We'll talk about that in 5 minutes, but that actually determines that, and there is no control over that because it's powered by something called XLAM like family of models, and it is different from the LLM which will be used to serve the response based upon the prompt. Yeah. Then once the index is defined, then you define some action. You can define flow, Apex, prompt, or MuleSoft. Then test the outcomes. And testing the outcome is very important. Right now, you can use the conversation preview within the agent builder. You can see the plan generated, test the outcome. But can you scale test there? What if I tell you that there are these 10, 100 types of different prompts, what will be the outcome? It's simply impossible to do that. That's why Salesforce introduced new Agentforce testing center. We'll talk about that next slide. Then once the outcome of that test is fine, then if it is fine, yes, you have a working agent. Congratulations. If it is not, the desired outcomes are not meeting your expectation, then go back. And where you have to go back is you have to go back, check your action instruction, the prompt template instruction, the topic instruction, the topic classification instruction. You have to revisit all those, tweak those instructions, then test it again, and it's an iterative process till you get the required response. So this is like the only way you can assure your customers or build. Yes, please. Yeah, exactly. Yeah, I've also that. To be honest, I think the only strategy is like delete it and do it again. Maybe it can be an idea which we can give to Salesforce to improve upon. But right now, I've also faced the same thing. Yeah, maybe with Agentforce 2.0, it is improved, but yeah, it's not documented at least in the features. But yeah, good. Yeah. Okay, so yeah, but thanks. I think that's a good input. I think yeah, there are still some tweaks. It's maturing, right? It's in the curve. It will improve. So this is just an example of an agent I built. So the topic is case assistance. I have a classification which says handle employee inquiries related to cases. So I'm kind of classifying my topic and I'm defining the scope, right? So look at the instruction. It's saying your job is to help employees retrieve case information and answer any questions based upon that case information. That is the scope. It is not supposed to update any data or anything. It's just supposed to query the case information. And the instruction, for example, the first is always format any dates in a human readable format, right? Simple instruction. And you can add n number of instructions here. So that is very important. Now, I was talking about LLM Decision Framework. So this is another framework which you can use to decide which LLM to pick. So the most important thing is what is your use case, right? And then based upon the use case, do you want to use an out-of-box LLM where I'm saying buy embedded vendor solution? In general, it could be Salesforce managed data model, or sorry, large language model, or build. And build is where you use the bring your own LLM capability. The important thing you need to understand is what will be the model size, what is the accuracy, what is the latency, whether you need a large context, high accuracy model, or you need a small model and apply quantization on that, right? And then you can also check whether you need a specific domain model or a general purpose model, depending upon your use case. And then if it is domain specific, do you need to fine tune it or not, right? And for general purpose, do you need to have the retrieval augmented generation capability or not? And then there are LLM leaderboards, in public domain available. If you Google for that, also check there that what other people are saying, right? And then make a very conscious decision, because this build part is not easy. It's tough. It takes time. It needs patience, and you need skill set on the team as well, right? Someone who knows SageMaker, who can write algorithm, if you are, for example, going to use SageMaker to build a model. But buying also, it's important, right? For example, for one of my public sector customer use case, we built an agent, and since it was public sector, the data was more proprietary, so we used cloud Anthropic cloud haiku model. Why? Because Anthropic cloud models, they are known for their ethical compliance. They have, their focus is that the model will not give you any response which is ethically not right, which is very important when you are dealing with healthcare public sector companies compared to OpenAI, right? So that's why we used cloud Haiku 3 model, which is a relatively small context model, but it fits use case. But again, you need to know, right? Some model are more ethically focused, some are more performance focused, some are others. So it depends. Yes. Yeah, great question. Today I was also in part of another presentation to end customer in a similar forum, and this question was asked by the end customer. I think the cost is depends upon how large the model is. So, for example, if you have a specific use case, uh, and you have a proprietary data, and you are not willing, even considering Einstein trust layer in between, still the data is, even if it is masked or something, it still goes and interacts with maybe OpenAI chat GPT-4 turbo model or some other model. And your organization guidelines are that no matter what, whether Einstein layer, whatever is there, the proprietary data cannot leave the trust boundary or of your organization. Then there is no other way, right? I mean, then you need to go for building your model and training it from scratch. But it depends upon whether you are then building a large language model, where like where the context size is much bigger, because I think that is the first mistake many people, when they start building the model or fine tuning the model, they do, because most of the use cases for a particular organizations are pretty restricted to a particular type of domain. So you don't need to really build a very large model and train it and build it from scratch. You can start with one use case and build a very small generate a predictive AI model or a generative AI model, and then run on it. And if you do that, then I would say the cost will be pretty similar, and in long run it will be cheaper.
I mean, it's a little bit
Sure.
Salesforce.
Yeah, the credits. Yes.
So if you bring
So there will be still data cloud credits, I believe so, because Einstein Studio bring your own model is a capability of data cloud. So there will be some still some credits. I don't know no, exactly whether it will be similar to how. I would say it will be relatively, the consumption of the credit will be relatively lesser, because you are not using, say, yes, go ahead. Mm-hmm. Yeah. Yeah. Yeah, so there is some difference. That's what I'm saying. Of course, I don't know about the knowledge article or have probably have read it, but don't remember. But if practically you see, right, their Salesforce is providing you a service by hosting the model and everything, and you are simply able to consume it. And there you are doing a lot of groundwork yourself with the bring your own model and all. So still there will be credit consumption because you are still using data cloud hosting infrastructure of Salesforce, but it won't be as similar as those LLMs as.
The cloud should have the box capability. All parts would be then
Yeah.
separate.
Yeah, model part depends upon use case actually. Yeah, like your data security compliance needs. Sometimes you have a use case where you need to train the model with your proprietary data. You cannot do that with the Salesforce managed model, right? I don't think there is a fine tuning concept there. So that's why. Those are the cases those qualify for bring your own model. Okay, how to test Agentforce testing center. Very easy. When you go to the agent builder, you will now see a button called batch test in the Agentforce testing center. That batch test is not available yet, but you will soon see it once the Agentforce testing center is available. You need to click on that batch test. A new pop-up comes, calls new test. You need to write test name, which agent are you testing. There is a drop down, so you can select a particular agent, which user would you like to simulate, and then description. And description says test a variety of realistic customer inquiries covering common topics like user account management, order status, product information. So you're giving this is again LLM powered, and then you select auto generate the test cases using agent topics and agent actions. So this is the only thing you have to do, and then all the tests will be generated by the Agentforce test center, and it will execute. So these are test utterances. So what it has done is it has generated different types of user queries based upon the instruction you have given. And then what is the agent result? Was the topic correctly identified? Was the action sequence correctly identified? Pass, fail, pass, fail. So you, yeah. Yeah, it's automated. This is the outcome of the agent testing center, Agentforce testing center. So it's fully automated. You know that, okay, for this kind of query, the action sequence was off. And then you can revisit those actions and see, or, if you can change the instruction or, guide your Agentforce agent a bit more so that this sequence is corrected, right? How will you, 10 minutes? Okay. How will I not? Okay. What if I not agree with? Then you can validate, right? Because see, this is a batch test where you have, let's say, executed hundreds of queries at one time. Then you can go to the Agentforce builder in the conversation preview. You ask that question manually, right? So if you go back here, you can always go here in the conversation preview and ask the same. Then a plan will be generated, and then you can seamlessly see whether it's right or wrong, right? So there is a validation. Okay, let's move on to the some more general topics before we wrap up. We talked about it already. So right now we are at this phase of AI, right? In Agentforce, we are at the monophonic phase, as we say in English, where the idea is that there is one agent, there is a frontline service agent, inventory specialist. You can create different agents, but they all talk to a service rep or whoever is chatting with them, a human. They don't talk with each other. That is the current state of Agentforce 2.0 as well for now. But where we want to reach at a stage called collaborative agents, right? This is what I was talking about, the manager agent or a supervisor agent, right? So there is an orchestration agent here. Service rep will only interact with the manager or the orchestration, and then the manager will decide which agent will serve that request. Could be inventory specialist, could be frontline service agent, could be logistic agent, right? And then generates the response, give it to the customer, right? So this is where the next step of this Agentforce platform is gonna be, right? Could be way sooner, maybe May 2025. Well, we don't know yet, right? Salesforce needs to confirm. Yeah, this one, yeah. Yeah, because you can always escalate it to human. If the agent says, hey, the orchestrator says, I tried with all my team members, sorry, this request cannot be served, let's bring a human. Yeah, humans are not going away for sure. The last one, the last one is ensemble, right? The last one is ensemble. So ensemble is where there will be cross-platform agent communication, right? We talked about it. So Microsoft agents, ServiceNow agent, Salesforce agent talking to each other. Of course, this is the next step. We need to come up with the protocol of the communication and different things, but eventually this will happen. There are already some architectures emerging in this space. Now, Salesforce Agentforce, I think you had a question, right? The Atlas reasoning engine is powered by something called large action model. It is different from the LLM, which is used by the prompt template to get the response, because that's based upon a customized prompt. But this is used by the reasoning engine because it is also powered by a large action model. So why do we call it large action model? Is what Salesforce does is that Salesforce has taken an LLM. It's built from scratch as per Salesforce. The information they shared, and they have trained that or fine-tuned that LLM with the different sort of actions which can be executed on Salesforce platform. It could be fire and apex, uh, get record action where you give that, okay, get case record, summarize the record, different actions, right? And it has trained that LLM so that reasoning engine knows that if you defined an action and assign it to a topic, reasoning engine can easily identify that this is the action I need to invoke because I know about those type of action. I know their prototype, right? So that is what Salesforce has done. And if you look at it, how it is working is that there is a prompt when meetings are on my calendar, what meetings are on my calendar this afternoon. This was the prompt. There's a large action model. It will execute an action saying, it will ask calendar app, send a function call called get schedule. Date is September 19, time is afternoon, and get the result. Now, Agentforce, another important thing is that there are multiple actions which could be the input of the next action, right? So for example, the prompt is organize a team offsite for Q3. So there will be first level of large language model action. It will generate an action. Then it will again give an input to LAM, and a second action will be performed, because this is a more involved query or a prompt or a request where the Agentforce has to take multiple action. And that is what reasoning engine sequencing does, right? I told you, right? When it has a planner service, it identifies the action, then it generates a plan that how those actions will be executed in which sequence. This is powered by LAM. Salesforce has these models, 4 models called XLAM family of models with different parameter sizes, 1B, 7B, 8 into 7B, 8 into 22B, depending upon the use case. And then they are trained, they are enhanced to handle different type of actions, and they use a concept called function calling, right, to execute different actions. So that is the concept they have used. So if we look at from a single agent to a multi-agent world, right, from a Salesforce platform, single agent, what it does is it has capabilities like customized trust layer. We know that it has seamless task execution capabilities, specialized expertise. But if we look at agent to agent communication, there will be an orchestration layer which will come into picture, and you can seamlessly plug in more agents in a multi-agent world, right? So this is how the platform is gonna evolve. Another concept is Salesforce Agentlite framework. This is a library published by Salesforce. It's available now on GitHub. I've included the link here. I'm not really sure if we're gonna share the slides, but we can put the link in. Yeah. So if you see here, this is Salesforce library, which you can use to build still a that manager agent, that orchestration layer, which I talked about. So the individual agent, right? There is a task, the individual agent, there is a prompt fed to LLM. It will act on that by executing actions. Then it will observe the outcome, put that in the memory, right? This is the individual system architecture. But manager agent, when it talks about Agentlite framework, there is a manager agent. It creates something called task package, right? So there is an instruction to manager agent, like a prompt. It creates a task package, and then it decides to which individual agent the task package needs to be forwarded to. And how it communicates is with a simple function call. And the individual agent responds, and then the manager agent does that, right? And with action. Go check out this library. I think there are some good insights about this is not really something which Salesforce will use for their multi-agent framework, because this is the concept, that how it works, and you can actually use it to build some open source multi-agents. But I think for Agentforce, there are some more nuanced changes that those are required. For example, probably these simple function calls will not work. It should be the async events, as we looked at earlier. Now, this is a view of, this is again from our World Economic Forum white paper, that there is an individual agent, which I explained the components, that there is an individual AI agent with control center, memory management, sensor, and everything. And then how it interacts with a multi-agent on platform orchestration layer, right? So there is an individual agent. It's one of the individual agent in the AI agent system, which is the multi-agentic layer. So there is an orchestration agent, and then there are multiple individual agent, and this agent one is this one individual agent. Now, this multi-agent layer can actually participate in another network of cross-platform multi-agent system, where this agent system is Salesforce, this is Microsoft, this is ServiceNow, this is some other platform, right? So this is how from one individual agent to multiple agent on platform and cross-platform architecture are going to evolve, and the system collaboration will.
Video
Mm-hmm.
where they had multi-agent as sort of Scrum team kind of thing. That it's like an autonomous team without a manager agent or
Exactly.
but like the
yeah,
let's say that
yeah,
use case that it's a development team.
mm-hmm.
You have a BA agent,
Mm-hmm.
an architect agent, and a software agent.
Yeah.
And they can independently decide who they want to interact with within
Yeah.
the same team.
Yeah,
and
exactly.
Only outside the team, they go for the manager agents.
Mm.
But within the team, they can decide directly,
Mm.
I want to talk to agent A, B, or C, as long as you.
Yeah. Well, in Salesforce could be, because on platform, and it's a good point Kate, you raised, on platform as well, one of the pattern is orchestration driven agents, but another pattern is network of agents, which you are talking about. And there that concept is that within same platform you can have a network of agents, and they have some protocol of communication and handling the request, maybe based upon capacity or other rules. But that is another pattern which can be applied within platform as well. There are many patterns. There is one slide which I'll talk about. This is just a glimpse of how a multi-agent can communicate with each other. When an agent one calls agent two, there are two options. One is you can pass the overall state to agent two, or you can pass something called LLM plus tools to agent two, right? I'll not go into the details, but these patterns are still emerging, and many platforms are trying to figure out how the communication will work, what are the protocols. And then this is how, when agent two responds, it can either share the full response execution, or it can just give you a filtered response, right? So how the protocols will emerge, how this will be standardized, yet to be seen. Yeah.
So you find the interface that's kind of input you can specify, and then
Yeah.
any two
Yeah.
argument setting you can.
Yeah. Yeah. Okay, so these are the various patterns. I just wanted to share that for you. So KID, for example, you mentioned, right, the agent architecture pattern. So you have solo agent, then two individual agent, agent to agent handoff, that is network, then multi-agent modularity, and then you can define different roles, whether it's an orchestrator agent or individual agent. Similarly, there are different evaluation patterns as well, like large language model as a judge, interaction logging, testing center, right? So different, and then communication patterns are also emerging, right? Function calling, you can use an API probably between agent. You can use something called generated code execution. So there are different patterns, but it's good to know which patterns are emerging, right? Uh, for the use case, I would like to quickly touch upon that. Every problem is not an agentic AI problem, right? That is the biggest mistake if you would do that. So what you need to do is, and this is a slide from Gartner, one of the webinar I attended, so I thought it's quite relevant to share that if you have a dynamic and unpredictable environment, you have complex decision making, you need continuous adaptability to the way a solution needs to be worked upon. You need to define autonomy and automation with less human intervention. There is an integration potential. Then actually it's a case for an agent. Uh, but just because you need to build a simple automation doesn't mean that you should build an agent just for executing a simple automation on the platform, right? So, I mean that every use case has to be carefully identified based upon these things. Yeah, rollout approach, crawl, walk, and run, no brainer here, right? Start with a simple agent with the limited knowledge and tools. Don't expose it to end customers first. Try it internally, more build an employee facing agent first. Once it's fine, then go to the walk phase and build internal and external, kind of an agent which can be exposed externally. And then also split one individual agent into multiple focused agent for scalability, as we talked about, domain specific, and then run, right? Then run phase is when you have agents in all teams, all business unit exposed to internal and external users. And also the agents can talk to each other, collaborating agents, right? And we'll get there, right? No one is in run phase right now, by the way. The future of Agentforce beyond the single task, I think what is coming in Agentforce is multi-intent support. What is multi-intent support is, for example, if you ask a query to Agentforce, book my flight and also book my hotel, right? Now, booking a flight is a different kind of a domain, even though it's booking, but it has to plan and do interact with different sort of data set, and reserve a hotel is a different data set. So how can you uh, send these kind of or ask these kind of questions, and the Agentforce can detect multi-intent and process it with its sort of action. Multimodal support, voice, vision, we know that it's coming. It needs to be there and it will come. Multi-agent support we talked about, right? It will come. Those patterns are emerging. The governance needs to be multilingual. Of course, for folks like who are in Netherlands, it's very important because customers always come back and they say, hey, we need to build an agent, but is Dutch language supported? Is Netherlands supported? And the question is, well, it's on the roadmap. The answer is, can we define the tone, that the tone should be kept professional? Oh, professional tone in English is different than the professional tone in Dutch or German or other languages. So can one set of parameters apply to every agent or every language? There are very different set of nuances, right? So every language has its own set of nuances, right? Maybe something which we say in Dutch very commonly in English, if you translate it using Google Translate, it may come across as rude, right? And vice versa. But that doesn't mean that it's rude, right? It's a language. It's those are the nuances. So we need to factor in that and respect that. And that is where the challenges are currently. We are already building some, exploring some agents with the company, and their biggest concern is this multilingual support and how the tone and will be and other things, right? Of the agent. First of all, it has to support Dutch as a language, because I don't see that in the roadmap of the languages, but we'll see.